Good morning, all of you. Today we are going to discuss graphical transformations. Suppose if you know the graph of f of x, then let us see how to draw the graph of minus f of x. For example, if you know the graph of f of x equal to e power x, then how can we draw the graph of f of x equal to minus of e power x? Let us observe the graphical transformation from e power x to minus e power x. In the Cartesian coordinate system, I am going to draw the graph of e power x. Suppose if the input is 0, then e power 0 value become 1. Next, if you give input 1, e power 1, that become e. You know that e is Euler number, that is approximately 2.718. So here I am going to select the value of e. Next, if I give input minus 1, that is e power minus 1, 1 by e, the value less than 1. Somewhere here I am going to put. Now, joining all these points, we get the graph of e power x, which is strictly increasing, right? This is the graph of e power x. Now let us observe the graph of f of x equal to minus e power x. Suppose the value of x is 0, then minus of e power 0, that gives the result. Minus of e power 0 is nothing but minus 1. So when you give input 0, output become minus 1, that is here. Next, if you put x value 1, e power 1 here, outside minus sign. So minus e, that is minus 2.718 approximately. So by x equal to 1, the output minus e here. Next, if you put minus 1 here in this, minus of e power minus 1, nothing but minus of 1 by e, that is less than minus 1, we get here. Joining all these points, we get the graph in this way. This is the graph of y equal to e to the power of minus x. Now observe these two graphs. Set of outputs, the points which are on the graph of e power x, now they are symmetric about x-axis in the second case, right? So when you put minus sign to the given function f of x, then you will get the graph which is symmetric about x-axis. So that you have to remember that the transformation minus f of x means, you have to remember that the graph which is symmetric about x-axis. If you remember this condition, symmetric graph about x-axis, then you can easily draw whatever the function given, then you can easily draw the graph of minus f of x. Let us observe different examples in this case. Suppose the question is, draw the graph of f of x equal to minus log x. Another question, draw the graph of f of x equal to x minus 1 into x plus 1. Suppose this is the question. Outside here it is of minus sign. You are familiar with the graph of log x first. So from the graph of y equal to log x, then you have to reach the graph of minus log x. And here in the second case, if you know the graph of x minus 1 into x plus 1, then you can easily transfer minus of x minus 1 into x plus 1. We know that the graph of log x with natural base exists only for all positive values of x. This is the graph of log x. This is y equal to log x. And the graph of y equal to x minus 1 into x plus 1, second degree equation indicates a parabola, and here the roots are minus 1 and plus 1. So this is the graph of y equal to x minus 1 into x plus 1. Now, using graphical transformation, you know that when you have outside minus sign, just draw the graph which is symmetric about x-axis. So now symmetric graph I am going to draw. This is the graph symmetric about x-axis. The graph which is entirely above x-axis, which is symmetric about x, means you will get the same graph here. Next, the graph which is below x-axis, since symmetric about x-axis, that goes here. So this is the graph of y equal to minus of log x, remember. Next, to draw the graph of minus of x minus 1 into x plus 1, what I am doing? Just symmetric graph about x-axis. That means the graph which is below x-axis, that you have to draw above, and the above graph you have to draw below. So reverse U shape we get. This is y equal to minus of x minus 1 into x plus 1, and first one white colored, that is y equal to just x minus 1 into x plus 1. So that, remember, in the transformation f of x to minus f of x, just simply draw the graph symmetric about x-axis. Let us move to the next transformation. Second transformation. Suppose f of x transform to f of minus x. What happens? Observe. For example, y equal to e power x and y equal to e power minus x I am going to choose. Just in place of x, suppose if you have minus x, then how to transfer this graph? Observe. E power x graph, we know that is rapid growth function, exists entirely above x-axis. Okay. Now let us draw the graph of e power minus x. At 0, e power x is e power 0 nothing but 1, and at 0 e power minus x graph, e power minus 0 nothing but again it is 1. Next, whenever x value 1, e power 1 nothing but e, but here it is 1 by e, remember. When you put x value 1, e power minus 1 gives 1 by e. 1 by e means the value less than 1 here. If you give input plus 1, e power, if you give input minus 1, e power minus 1, 1 by e, but e power minus x value become e power minus of minus 1. I am going to give input minus 1. So minus of minus 1 become plus 1, e power 1 nothing but e. E value approximately 2.718. Joining all these points, this is the graph. So what you observed from this figure? Clearly the graph is symmetric about y-axis. You have to remember this. clearly graph is symmetric about y-axis. So using this condition, you can transform the graphs of f of minus x. Let us discuss with different examples. Suppose the question is, draw the graph of f of x equal to log of minus x, and another question, draw the graph of f of x equal to sine of minus x. See the transformation in both the cases. First you have to draw the graph of log x, and then transformation log of minus x. Here first we have to draw the graph of sin x, and then go for transformation sine of minus x. You know the graph of log x. Log x graph, that is for natural base it is log x. When x changes to minus x, then you have to draw the graph which is symmetric about y-axis, right? Just now we discussed the transformation here just symmetric about y-axis. This is y-axis and this is the function. Now f of minus x means you have to draw here symmetric graph about y-axis, means this is the final output. Previously you have the graph like this. Symmetric graph about y-axis means the same graph here you will get. This is log of minus x. Just by getting symmetric graph about y-axis, you will reach the solution. Next, sin x graph. You know that sine wave this is the graph of sin x, right? Here it is 0, maximum 1, minimum minus 1. When you have sine of minus x, symmetric graph about y-axis, right? So that what happens, observe, the graph which is in the first quadrant, that is symmetric about y, means exists here. Next, the graph which is in the fourth quadrant, symmetric about y-axis, means that goes here. The same wave continues, so that you will get the graph in this way. This is the graph of sine of minus x. Without substituting the values of x, directly if you draw a symmetric figure about y-axis, you will reach the graph of f of minus x. So this is the way of drawing f of minus x. Let us move to third one. Suppose f of x to f of x plus a. Given function f of x, transformation, suppose f of x plus some constant, and constant is more than 0. What happens, observe in this case. And after that, next transformation, f of x to f of x minus constant, constant more than 0. See the transformation in both the cases. here suppose the question is draw the graph of y equal to x square plus 2, and here suppose the question draw the graph of y equal to x square minus 2. First you have to draw the graph of y equal to x square, and then you have to add 2 units and you have to subtract 2 units, right? In the transformation, plus 2 is there, minus 2 is there. You are familiar with the graph of y equal to x square, and after that you have to draw the graph of x square plus 2. First draw the graph of x square and then go for transformation x square minus 2. You know that the graph of x square, that is parabola u shape passing through origin. This is the graph, right? Yes. Now to draw the graph of x square plus 2, just shift the graph 2 units in the upward direction. Why? Because here by substituting x value 0, 0 square becomes 0. But here when you write x value 0, 0 square plus 2, that become 2. Previously when you put x value 0, output 0, but here 2 units extended, so that output you will get here 2, and then the graph, the same U-shaped graph, but that transfer 2 units in the upward direction of y-axis. So that here I am going to write shift the graph k units towards positive direction of y-axis. If you remember this condition, you can easily transfer any type of graphs. Next, x square first, that is U-shaped graph. When you have minus 2, each and every output decreased by 2 units. Nothing but the graph exists in this way. Same U-shaped graph, but that shift 2 units in the negative direction of y-axis. That is, here you have to remember, shift the graph k units towards negative direction of y-axis. So these are the transformations when you have plus k and minus k. Let us discuss different examples. Suppose the question, draw the graph of y equal to e power x plus 3. Next question, draw the graph of y equal to x power 3 plus 1, y equal to x power 3 minus 1, and the graph of y equal to e power x minus 2, y equal to x plus 2, y equal to sin x plus 1. See the graphical transformations in all these cases. Yes, we know that the graph of e power x, from this you have to draw e power x plus 3. E power x graph, rapid growth function, and this is the graph. When you have plus 3, you have to shift the graph 3 units. 1, 2, 3 units above, so that you will get the graph in this way. This is the graph of e power x plus 3. Next, here you have e power x minus 2. You know that rapid growth function, exponential function, e power x graph, this one. When you have minus 2, just you have to shift the graph in the negative direction of y-axis 2 units. First 1 unit and then 1 unit. So you will get the graph of e power x minus 2 in this way. Next, x cube plus 1 graph. You know the graph of x cube. This is the graph of x cube. Right? Now, when you have plus 1, entire the graph you must shift 1 unit upwards. So this is the graph. Next, x cube minus 1. You know the graph of x cube. This one. When you have minus 1, you have to shift 1 units in the downward direction. So this is the graph. This is x cube minus 1. Okay. Next, y equal to x plus 2. You know that y equal to x, straight line passing through origin, that makes an angle 45 degrees with the positive direction of x-axis. When you have plus 2, transfer 2 units above. The entire graph transfers 2 units above. This is the graph. Next, y equal to sin x plus 1. We know the graph of sin x. Sine graph defined for all x belongs to R, maximum 1, minimum minus 1. And this is the graph extension to this. Now, if you have sin x plus 1, that means you have to shift the graph 1 unit above, so that the graph become like this. This is 1 unit above. 0 goes to 1, 1 goes to 2. 0 goes to 1, minus 1 goes to 0. This is the graph. And the graph exists in the interval 0 to 2, remember. The entire graph, which is shifted 1 unit in the upward sense, so that this is the final graph of sin x plus 1. And you know that usually sine graph exists in the interval minus 1, sine graph whose range is minus 1 to 1. When you have sin x plus 1, that is, you have to add 1 unit, then what happens? Adding 1 it is 2, adding 1 it becomes 0. So sin x plus 1 graph whose range from 0 to 2 exists. So this is the graph of sin x plus 1. This is the way of transforming graphs from f of x to f of x plus k and f of x minus k. Move to the next transformation. Suppose f of x is transformed as f of x plus k, internally k units added, where k positive. Next, transformation from f of x to f of x minus k, k more than 0. Let us see these transformations. What happens when x transform to x plus k and x minus k? Let us observe. Suppose that f of x equal to x square and f of x equal to x plus 2 whole square. Next, suppose f of x square, f of x is x minus 2 whole square. First, let us observe the difference and then we go for the condition. You know that y equal to x square, that indicates a parabola, it is passing through origin. This is the graph of y equal to x square, right? And next you have to draw the graph of y equal to x plus 2 whole square. When you put x value minus 2, minus 2 plus 2 becomes 0. So at x equal to minus 2, the graph becomes 0. When you put 0, it is 4 here. And when you give input minus 3 plus 2, minus 1 whole square plus 1 here, joining these points, we get the graph in this way. The same U-shaped graph, just it is shifted 2 units in the left side, right? Next, here you know that y equal to x square, that indicates U-shaped graph. When you have minus 2, what happens? Observe. When you have minus 2, then simply you have to shift the graph in the right side just 2 units. See the graph? Here, if I write the value of x as 2, 2 minus 2, that becomes 0. So at x equal to, it is 0. Next, if you put x value 1, 1 minus 2 whole square, 1. Next, if you put 3, 3 minus 2 whole square, 1. So that now joining these points, we get the graph in this way. What you observe? The same U-shaped graph, when you have plus 2, it is shifted 2 units in the left side. And here, when you have minus 2, the graph shifted towards right, along the direction of positive x and negative x here. So that I can write here, just shift the graph k units towards left. Entire graph k units towards left when you have plus sign. For plus sign, remember here we are going to shift left side. Next, here in the second case, shift the graph k units towards right side. Okay, when you have negative sign, you have to shift right side. For positive sign, you have to shift left side. Yes, let us discuss the same transformations with different examples. Suppose that y equal to modulus of x plus 2 and y equal to modulus of x minus 2. Y equal to e power x minus 1. Next, the graph of y equal to log of x plus 1. Y equal to x plus 1 whole power 3. Next, y equal to fractional part of x minus 1. Let us observe all the graphs. We know that mod x graph, that is U-shaped graph, sharp edge at origin. Usually this is the graph of mod x, right? From mod x you have to transfer mod x minus 2. From e power x you have to transfer, right? This is actually e power x. From e power x you have to transfer e power x minus 1. You know the graph of log x. Next we go for transformation. Next you know the graph of x cube. You know the graph of fractional part of x. Now let us observe the transformations. Yes, when you have plus 2, just now we discussed, you have to shift the graph 2 units towards left. The same graph you have to shift 2 units towards left. That means here it is 2, and V-shaped graph that has sharp edge at x equal to 2, this is the graph. Next, when you have minus 2, when the value of k is minus 2, then for negative quantity you have to shift the graph towards right. Therefore, you will get a sharp edge at x equal to 2. This is the graph. Next, e power x minus 1. Just shift the graph 1 unit towards left. So, here it is of 1 unit height that you must get here. You must get in the right side. Why? Because here you have minus 1. So, 1 unit height at 1 you must get. Actually here the graph of height 1 unit at particularly 0. When you have x minus 1, that is the graph of height 1 unit at x equal to 1. If you get input 1, 1 minus 1 becomes 0. E power 0, that becomes 1. So, just shift the graph 1 unit towards right. So, this is the graph. The graph is shifted 1 unit. Next, log x graph. From log x to log of x plus 1. You have plus 1 here. So, shift entire graph. Actually, this is the graph. You have to shift the graph 1 unit towards left, so that you will get the graph in this way. This is the graph of log of x plus 1. When you have plus 1, shift the graph 1 unit towards left. Next, x plus 1 whole cube. You have plus 1, right? So that 1 unit left you have to move, so that the graph exists in this way. Here it is minus 1. Here actually it is 0. The same graph shifted to minus 1. Next, fractional part of x minus 1. Fractional part of x minus 1 graph. Yes, you have to shift the graph 1 unit towards right. If it is shifted to 1 unit towards right, you will get the same graph, right? The first graph, which is in the interval 0 to 1, that goes here 1 unit right. Okay. Next, in the interval 1 to 2, the graph which you have, that goes to, first in the interval 0 to 1 goes to 1 to 2. Next, the interval 1 to 2, whatever the graph you have, that goes to 2 to 3. So, the same graph you will get. So, this is actually equal to fractional part of x. You know the property, fractional part of x plus integer quantity, again fractional part of x, so that the same graph we get in both the cases, remember. This is about transformations when x changes to x plus k or x minus k. Next transformation.